This video is going to take us through our study guide for our Systems of Equations unit. So start filling this out as we go through this video, and then it'll be a good study guide for your test that we're going to have coming up. Okay, so the first thing we're going to do is do a review of the graphing method. So you want to use this when both of your equations say y equals. So all we need to do is graph these two equations on the coordinate plane, and then wherever they intersect will be our answer. So let's graph this first one, y equals negative 2x plus 1. So I'm going to plot my y-intercept, which is a positive 1 first. And then my slope is negative 2, which is negative 2 over 1, keep in mind. So when I rise and run, I actually need to go down 2 and run 1. And then I'm going to do that again, actually. Make sure my line is long enough. And then I'll go ahead and connect those. Okay, and then let's graph the second one. Y equals 2x minus 3. So I'm going to come down to negative 3, plot my y-intercept. And then this time my slope is 2, which is 2 over 1. So that means I need to rise 2, run 1, and it's going to hit right where that dot already was, which is perfect. Okay, so you can see they're going to intersect right here, and we just need that ordered pair. So that would be 1, negative 1 for your answer. Okay, so we're just going to do one of those for the graphing method since we spent our entire last unit on graphing. We're going to move on to the substitution method. So substitution, remember this is where you're going to plug what y or x equals into the other equation. Excuse me. Now, for number 2, it's a little bit different because they both say y equals. So if I had the choice, I would put these on a graph and figure out where they intersect. But to get a little extra practice with substitution, I'm just going to take one of them. Doesn't matter which one because they both equal y. So let's say I take this top one, and I'm going to plug it in for y down below. So that's going to become negative 6x minus 3 equals negative 7x minus 4. And then I just need to solve this. So I don't need to distribute anywhere. I can't combine any like terms. So that jumps me right to getting my variable on one side. So notice you have an x on each side of your equal sign. So I need to move one of those over. So I'm going to move this negative 7x. I'm going to add 7x to both sides. Those will cancel. So on your left-hand side, we have negative 6x plus 7x would give you a positive 1x, but remember you don't need the 1 there. So I'm just going to put x. Everything else I'm going to bring down. So x minus 3 equals negative 4. And then I just need to add 3 to both sides. So x is going to equal negative 1. So that's x. And now I just need to figure out what y is going to be. So both of these equations say y equals, so it doesn't matter which one you plug it into. So let's just do the top one. So we have y equals negative 6x minus 3. So I'm going to take this negative 1, and it's going to go in place of the x. So negative 6 times negative 1 gives you a positive 6, and then 6 minus 3 is 3. And then remember we have to write our answer as an ordered pair, so this would be negative 1, comma 3. Alright, let's look at number 3. We have 9x minus 8y equals negative 18. And then x equals negative 10. So this one's nice and simple because they already gave me x. X is negative 10. So I'm going to take that, and it's going to go right in place of the x up above. So we're going to have 9 times negative 10 minus 8y equals negative 18. And I just need to solve that. So 9 times negative 10 would give you a negative 90. Everything else I'm going to bring down. Next I need to add 90 to each side to get rid of that. So now I'm left with negative 8y equals, and then negative 18 plus 90, you just subtract those, so you would get 72. And then divide by negative 8. So y is going to equal negative 9. And then the original problem already gave me what x was, so I can just jump straight to my ordered pair, which would be negative 10, negative 9. Okay, so that's substitution method. You're just plugging what x or y equals in for the other equation. So now we're going to jump into the elimination method. So remember, with the elimination method, you're wanting to look for opposites because you want something to cancel out. You want something to eliminate. Okay, so let's look at number 4. We have 7x minus 8y equals negative 16. And then negative 7x plus 6y equals negative 2. So I notice right off the bat that my x's are opposites. They're going to cancel out and make 0. And then we just need to add the rest of it together. So negative 8y plus 6y would give you negative 2y. And then negative 16 minus 2 would give you a negative 18. And then all we need to do is divide by negative 2 on each side. So y is going to equal a positive 9 because the two negatives make a positive. But then we still need to find x. So we have two pretty similar equations up above that we started with. So let's say we use the top one. So I'm going to plug this 9 in for y right there. So I have 7x minus 8, but instead of the y, I'm going to put the 9, equals negative 16. Now, negative 8 times 9 is negative 72, so this would be 7x minus 72 equals negative 16. And then I need to add 72 to each side. So 7x equals, and then really, this is just 72 minus 16. You get 56. And then finally divide by 7, so x is going to equal 8. And then remember, our answer has to be an ordered pair, so 8, 9 would be your ordered pair. All right, number 5. Same thing, we're going to use the elimination method, but this time nothing is canceling. I don't have any opposites with my x's or with my y's. So what we're going to have to do is we're going to have to change one of them. So one thing I noticed, my bottom equation has just x and y, so those are going to be pretty easy to change. So I'm going to change that second equation. But which variable do I want to cancel out? It really makes no difference. I'm going to lead more towards the x's because one's negative and one's positive already. So I won't have to worry about having to change the sign. So if I can make this x right here a positive 6, then it's going to cancel with the negative 6 right above it. So to make that a positive 6, I'm going to have to multiply by 6. And don't forget, you have to multiply the entire equation by 6. Okay? So this is going to become 6x minus 6y equals, it's going to be negative. I just need to figure out what 17 times 6 is. You get 102. Okay? So now this equation has gone away for the time being. I'll probably come back to it in just a minute. But let's get these other two added together. So your x's will go away. You have negative 9y minus 6y. That's negative 15y. And then negative 18 minus 102 would be negative 120. And then we just need to divide by negative 15. Two negatives are going to make a positive. And 120 divided by 15 is 8. So y is going to be 8. Now I still need to figure out x. So I actually want to come back to this original second equation right here just because it's so simple. And I'm going to plug my 8 into that one. So it's going to become x, grab my pen here, x minus 8 equals negative 17. So then all I have to do is add 8 to each side. So x would equal negative 9. And then your ordered pair would be negative 9, 8. Okay, so that's the elimination method. So the last three that we're going to look at is going to be something new. We haven't talked about this before, but it's a pretty easy concept to pick up on. So the question is just simply asking how many solutions is this system going to have. So everything that we've solved so far has had one solution. Like in number 5, negative 9, 8 was your answer. It's one answer. You didn't have multiple answers to any of these. Okay? So let's look at some where you may have more than one answer, or you may not have an answer at all. So let's look at number 6. First equation is y equals 4x minus 2, and the second one is 2y equals 8x minus 4. So some of you may already notice a pattern with these two equations. If you didn't notice it right off the bat, take a look at that first equation and then look at the second one. Is there a pattern to how they got the second equation? So I noticed that all they did was take this first equation and multiply it by 2. Y times 2 is 2y. 4x times 2 is 8x. Negative 2 times 2, negative 4. So it's the exact same equation. All they did was just multiply it by 2. So if you were to graph these on a coordinate plane, it may look something like this. But then when you go to graph the other one, it's going to be the exact same line. So when we're thinking about where do those two lines intersect? Well, they intersect all along this line everywhere, okay? And keep in mind, those lines go on forever. So, since these are basically the same equation, same line, we would say that this one has infinitely many solutions. And I'm going to add in an explanation here. And I'm just going to say because the first equation has just been multiplied by 2. So anytime you have a pattern like that, it could be multiplied by anything or divided by anything to get that next equation. Then it's going to be infinitely many solutions. Okay, so let's look at number 7. Y equals 3x minus 4, y equals 3x plus 7. So I already noticed there's no pattern between the two of them. They're two different equations, but what I do notice, something that they have in common, is this right here. They both have a 3x. So if you remember, back to our slope-intercept form, y equals mx plus b. M is your slope, right? They both have a slope of 3. So if I were going to graph this on a coordinate plane, say that's negative 4, and I'm going to rise 3, run 1. Let's say that first equation looks something like that. The second one, I'd have to come way up to 7, rise 3, run 1. It's going to look something like that. I applied the same slope to each line. So if you notice, these two lines are parallel. So are they ever going to cross each other? No. So we would say this one has no solution because they are parallel lines. Parallel lines never cross. All right, and then let's look at the last one, number 8. So we have y equals 3x minus 4 and y equals 1/2 x plus 3. So first thing I'm checking for are any patterns going on. I don't see any. They're just two totally different equations. And then I'm going to look at the slope. Well, they have two different slopes. So these two equations have nothing in common. So they're not the same line, so it's not going to be infinitely many solutions. They don't have the same slope, so it's not going to be no solution. So this one would just have one solution. This is like all of the others we've been working thus far. They're going to have one point where they cross. One point that's in common with both equations.